Hello, this is Preston Lee, co-investigator and tech lead for the ASU Shares program at Arizona State University. 2024 was an extremely busy year for us, not the least of which was refactoring much of the common code that we're using in the applications that we demo into a reusable shared library that we've also published publicly. I believe we referenced this in the paper that we published in 2024, and we're going to continue building on that within 2025 deliverables. At ASUshares.com, we've put up a couple illustrations that show deployment architectures particularly relevant to 42 CFR Part 2 and the exchange of substance use records across organizational boundaries, typically between two providers. The one that we're going to focus on today is this Shares Architecture E, which is the notion of a patient that sees multiple providers that are somehow involved in the coordination of care, or at the very least need access to the same to the records of a given patient in a more longitudinal manner. So in order to help visualize this, we have a completely new tool that I'm going to show that we consider the simulator, which is an amalgamation of work that we did in 2024, as well as integrating our 2025 work into a simple single-page UI. Now, this simulation concept is currently built into the Shares Provider Portal proof of concept. It seemed to make sense, at least to try putting it here, because the Provider Portal idea is to present as complete of a picture of what a consent directive provided by the patient means. So having some simulate buttons that directly tie into that, it seemed to make sense. So we've prepared 3 de-identified patient records here. For purposes of this demo, we're going to look at Kobe King, but we can easily run through it with these synthetic patients, with these de-identified patients. And in the future, we'll also be doing this with synthetic patients that have much more diverse histories to them. Let's take a look at the consent document before we actually start simulating it. This particular patient, and the consent is not real, by the way. We created the consent, but the underlying medical records are. So this patient has elected to deny all sharing with all organizations, because the enforcing organization here is blank, which means everybody. So they want to deny all sharing except for except for data labeled as mental health, substance use, or violence related for purposes of treatment and research. So in other words, they would like to deny all sharing for any purpose other than treatment or research, and only in these 3 selected categories. Okay, so easy enough to understand, but now how does that actually work in practice when we have these complex records and they don't cleanly fit into one of these or 11 categories or more? So now we have this new simulate button up here. I'm going to go ahead and click that, and that's going to load up our simulation page. There's a lot that's going to happen here, so it's going to take a few minutes just to kind of explain all the various controls and options. The first thing about the simulator is that we're focusing on a single patient at a time. If you're familiar with the FHIR specifications of consent, it doesn't necessarily have to be a patient. Our simulator assumes it is one and only one patient, as well as that we are simulating one consent document at a time. Neither the specification nor regulations say that there's only one consent document. So in the future, we may want to simulate multiple consent documents simultaneously, or maybe the absence of a consent, or maybe an incomplete consent. But as of Q1 2025, we're starting with single patient, single consent simulation. Okay, this first set of controls here is to select the engine. Now, for the first year or so of Shares, we focused pretty much exclusively on a CDS hooks-based mechanism, using a new type of hook with CDS hooks to be able to label and redact individual data objects from a FHIR server. We are continuing to develop that, to do it at a bigger scale and to add additional features to that. We also have a second implementation, which is not as baked, but does work, using clinical quality language. So rather, instead of using very simplistic rules to try to determine if a given data object is or is not substance use, for example, we can use CQL to do much more complicated contextual reasoning, as well as look up similar codes for clinical conditions or laboratory values and so on, and consider data more in a broader patient context as opposed to just isolation. So if we select CQL, there's going to be some different options here, and this isn't quite ready to provide as a public demo yet. So we're going to go back to CDS hooks. All right, the second set of controls here is caching, which I'll get to, but to show why we need that, I'm going to unselect these and select or click Request Patient Export here. Now, this is going to run for a while. And the reason for that is what it's done is it's made a request to our stand-in EHR server, which is really just a FHIR server that holds the entirety of Kobe King's medical record. It is not a fast operation to do. So it is not something you would do in real time. Production servers are going to take much longer than this. It might even be an overnight type thing to request. So rather than sitting here just waiting an indeterminate amount of time, what I've done prior to recording this is selected these caching options. And so once you go through that for the first time, the browser can save that bundle of FHIR resources that's aggregated together and save it to your browser's local cache, so that the next time you request a patient export, it will simply load it instantaneously from your local disk, and you don't have to wait 5 minutes every time. Massive time saver. Okay, so that's what that does. And then, of course, if you want to re-export data from a FHIR server, you can click that and get to wait, say 5 minutes again. Moving along, the exchange simulation area. Okay, so this is how you control the input parameters to how our underlying engine behaves. Now, the CDS hooks-based engine has just a couple different controls to it that you can mess around with. The most important one is a confidence threshold. So when the CDS hooks engine looks at the data all of the patient data that you provide to it, it has simple rules, but it does assign a confidence level to each of those outcomes. So in many cases, it's very clear that if there's a specific diagnosis code, that's 100% considered a disease-related record or communicable disease-related record. On the other hand, it may be really ambiguous or indeterminate without any sort of context associated with that data object, if it is or is not substance use or any of the other categories. So to start our demo here, I'm going to just leave that at 0, and then I'm going to define the purpose of the sharing that we are simulating, and click Run. So in cases where the patient has not elected in their consent document to share data for treatment, for example, if I run it again, or if they don't want to share it for research purposes, this would have come back with all denies, just blanket denial, because the consent just simply does not permit that. So these two checkboxes are mostly useful just for checking if those blanket denials or permits are going to be honored. Okay, so what we see here now in the results, which was very quick, is really the combination of all of those different inputs in column format. The first two columns are really just the raw data as it was provided from the EHR or our FHIR server in kind of an unsorted format. The first column is the type of data as it would be called in FHIR: conditions, observations. It's where your labs and vital signs would be, for example. The second column is displaying any sort of human readable text that's associated with that data instance over here. We're only displaying what's provided to us from the EHR and not doing lookups, so sometimes it's missing completely. You'll see the consent document come up here as well, because the EHR decided to export the consent itself, and that's fine. We've not labeled it in a certain way, but it's nice that it's there. The patient demographics, or the patient object, the highest level patient record object itself, is also present here, which is good to see. Okay, the third category now is how our engine decided to label that that aspect of the data record. So you'll see that, acute psychosis as a condition has been labeled relevant to mental health, schizophrenia the same way. You'll see the absence of labels that you would say, hey, this should be labeled a certain way. Why isn't that way? Well, then that's something that we would need to fix in the engine as one of its inputs in its kind of master rules file. Or maybe it's just a deficiency that we can't fix because the engine has no, the CDS hooks based engine has no broader clinical context as to what was going on at the time a given piece of data was labeled a certain way. The last column here is really where the rubber meets the road, and that's really the final decision that we've made as to whether or not, given all of these other inputs, that data entity should be shared across the wire. We've also built in the ability to filter out. So for example, here, if I only want to show data labeled as mental health, violence, and substance use, I'm going to click those and we'll see a results table only displaying things that the engine has labeled in that way. Or maybe you want to only show things that weren't labeled in that way. So then you can scan the list and look for deficiencies and things that we need to improve internally. All right, I'm going to select only data labeled as here. Now, what I'm going to do to show how the confidence threshold works is just kind of jack this up a little bit to maybe, 60, 70% or so, and then rerun the simulation, and you'll see that list got a little bit smaller. If you make it even higher to 100, depending, got even smaller. So that kind of shows you how easy it is now to visualize what the engine is actually producing, instead of having to create these technical JSON documents and write API scripts to be able to do these things as we had to do last year. So this simulator tool is probably going to be a big focus, not just for 2025, but as a single pane of glass to show the performance of engine A versus engine B, and then going through these sorts of demos now with broader types of synthetic data and for other types of substance use related use cases that we haven't even thought of yet. So I'll go ahead and wrap the demo here. Thanks for watching.